nos dias 17 e 19, estaremos com os maiores especialistas em diversas áreas com vocês. We are going to stay with a lot of specialists during the next days, November 17 today, and November 19, we have 2 intensive days. Thank you very much for WNA to stay with us. Muito obrigado a WNU por estar conosco, né? Mais uma vez. Thank you very much, WNU, to stay with us one more time. After 10 years, we make the WNU in Brazil. Thank you very much, all the team of WNA. Muito obrigado a todos os amigos da WNA por continuarmos realizarmos a WNU nos últimos 10 anos aqui no Brasil. We are going to introduce Mr. King Lee. He's one of the manager of the WNU at this moment, and he's going to present all the people and present the WNU for 2020. Muito obrigado a todos, obrigado Mr. King Lee por estar conosco, e passo a palavra a Mr. King, que irá nos apresentar e abrir oficialmente a WNU 2020. Mr. King Lee, please.
Sasso, thank you very much. Good morning, everyone. I'm King Lee, the Director of Harmony Program from the World Nuclear Association. I would like to welcome you today to the World Nuclear University Brazil online short course on the World Nuclear Industry Today, prepared in close collaboration with Abdan. The World Nuclear University is a worldwide network of educational and research institutions engaged in peaceful use of nuclear energy, radioisotope production, and the application of ionizing radiation in medicine and industry. WMU mission is to enhance international education and leadership in the peaceful use of nuclear energy and the application of nuclear science and technology by providing top-level training for future world-class nuclear leaders. The pillars of WMU are the 4 founding supporters. On the government side, you have 2 main international nuclear agencies, the IAEA and NEA of the OECD. On the industry side, we have the 2 main global nuclear organizations, WANO and WNA. WNU is a growing international network of educational and research institutes. Currently, the network includes 2 international intergovernmental organizations, 9 international and regional associations, and 62 institutes in 30 countries. If you'd like to know more about WMU, please visit the website or visit our stand at the virtual conference. WMU offers a range of unique and cutting-edge competence building programs around the world. There is a particular emphasis on leadership and communication skill development by drawing on the support of industry, government, academia. These programs are designed to meet the training requirements of international nuclear professionals. Almost 8,000 participants from over 90 countries have attended WMU programs. At the heart of WMU program is the Summer Institute, WMU flagship event aimed at promising young nuclear professional and graduate students. The WMU Summit Institute is a 6-week training course attracting 70 professionals from around 30 countries each year, enhanced by practical workshops, interactive platforms, and a visit to nuclear facilities. The WMU provide a multicultural and dynamic learning experience essential for building a global network and developing key leadership skills. The Summit Institute is to provide a unique educational experience aimed at building future global leadership in the field of nuclear science and technology. The Summit Institute provide cutting-edge presentation and workshop in a range of topics relevant to leaders, including goal setting, international regime, nuclear laws, nuclear industry and application, and leadership, project management and knowledge management, and effective communication. Moving to the World Nuclear Industry Today short course. The course focuses on providing practical knowledge and global perspective and an exciting vision of the future. The short course provides a training program delivered by the world's foremost expert in a cost-effective way. The World WMU short course is designed to enhance knowledge of the attendees about the status of nuclear energy in the world today and its likely development. The course also aims to inspire attendees to further their career in this exciting and expanding field. For the participants, the expected outcome of the WMU short course are improved knowledge about nuclear energy in the world today, recognition of how local skills and experience fit into global nuclear picture, inspiration to develop an expansive vision of where the industry can go in the future, networking with nuclear professionals in their countries, and the international experts. Regarding the current status of nuclear development, since the first over 60 years ago, nuclear energy started commercially. Last year alone, nuclear power delivered as much as electricity as the entire global electricity output from all sources in the 60s. With economic development, population growth, today's nuclear share of almost 400 gigawatts, about 10.5% of the global electricity generation. There are 441 operable reactors, and further 54 reactors are under construction. And recently, in this year, new nuclear power plants are being commissioned: Belarus, China, Russia, and UAE. We celebrate this success. New build in China and Russia have shown that it's possible to have an ambitious program for more nuclear power plants, where plants are built to time costs. Brazil is progressing with its plan for more nuclear power, and is pleased that with this cause to support the development of human resource and technology. WMU is proud to be collaborating with Abdan on this course. You will learn more about recent international nuclear development shortly in this course. This morning, we will learn more about nuclear energy development in Brazil, the South America region, and international nuclear new build. followed by a session on international and investment and financing of nuclear development. This afternoon, the session on nuclear supply chain will include presentation on selected topic from the WNA Supply Chain 2020 report, followed by a discussion with key Brazil nuclear companies on delivering an effective supply chain. On Thursday morning, there's a session on communicating about nuclear energy. We'll learn about effective nuclear communication and practical example of press communication. And in the afternoon, there will be a session on nuclear education and training with more information on WMU nuclear educational programs, followed by a discussion on nuclear education in Brazil. You have opportunity to ask questions to the experts, make good use of these chances. Thank you very much for the exciting group of lecturers who are in different parts of the world right now, but connected to all of you. The incredible class of hundreds of students and people from the nuclear industry. With all the changes that were due to the pandemic, educational method need to adapt fast, and I believe this will only begin a new way of transferring knowledge. This event should be viewed as a simple training for nuclear professionals, but also expect you to recognize how your own skill and aptitude fits within the global energy picture and network. We have a simultaneous translation feature at the event. By clicking on the global icon on the command bar below your screen, you may then select original audio, English or Portuguese. The course is being recorded and will be available afterward through the WMU website. If you would like to know more about WMU, please visit our website. I would like to introduce your moderator, Mr. Orpet Peixoto, for the session on global, regional, and national nuclear development. I'll hand over to Mr. Peixoto. Thank you and enjoy your course.
Thank you, Mr. Lee. I'm Orpet Peixoto. Good morning, ladies and gentlemen, my colleagues, all people on this course. I will be the moderator for this first section in the morning here. And the section is intended to cover the global, regional, and national nuclear developments. So we will have 5 speakers during this morning. The first 2 speakers will try to cover an overview of the developments around the world on the nuclear industry. The intermediate speaker, Dr. Federico, is going to deal more on advanced reactor technology. And the last 2 speakers that are Eletronuclear professionals, they will cover the national view of this development. The flow of this section is going to be like each speaker will make the presentation in a sequence, and we have at the end questions and answers. Please, if you have any question, any comment, put on the chat, and we'll try to address at the end of the section. Okay, said that, let's move for the first speaker. Okay, this is Mr. Milton Kaplan. Let me read briefly his bio here. Mr. Kaplan has more than 35 years in nuclear industry. He is specialized and advises governments and utilities on how to increase confidence and reduce risk on nuclear projects, okay, with focus on manage nuclear projects for success. These advice including such areas as the cost nuclear plants, economic competitiveness relative to alternative technology, structuring a project to be financeable, and to minimize the risk, and advise on how to best select a vendor and a technology. He is the chair of WNEA Economics Working Group and teaches nuclear economics, nuclear plant instruction and financing, and nuclear technology. Thank you, Mr. Kaplan. You have the floor.
Thank you, Orpet. Bom dia, good morning to everybody. I'm so excited to be here. As Celso said, this is 10 years of WNU in Brazil, and I can tell you that I have participated in every single one, and I'm so excited to have that opportunity and that experience. It's been a wonderful experience. I've been able to see much of Brazil, and I can assure you, sitting in my office in Toronto, Canada this morning, where it's much earlier, it's only 7:20 in the morning, and if I look, it's only 2 degrees here today. I really wish I was with you all, and I hope next year we can be together. I'm going to give you a very general introduction and update on what's going on in the global industry so that we can all get to the same place to help set the scene for the speakers that will follow. There we go. Much of this information comes from the World Nuclear Association Nuclear Performance Report 2020, which is available on the World Nuclear Association website. If we take a look at the past year, 2019, we saw once again an increase in the amount of energy that was generated by nuclear power around the globe. This is the 7th successive annual increase, so that's some good news. As King mentioned earlier, we have about 400 gigawatts of operable nuclear plants, but the number is increasing, but relatively slowly. If we look at the regional developments in 2019, I think it's no surprise to everyone that we can see that the largest growth is in Asia, led by China, and in Russia, you can see, and Eastern Europe, some growth. I think you may be surprised, though, when people think that nuclear is struggling in Europe, to see that there is some growth in Europe with projects underway in Finland and UK and France, for example. And in South America, as you can see, that is you, my friends, in Brazil. And in North America, it's the one project happening at the Vogtle plant. Now, in 2019, there were 6 reactors connected to the grid. What's of real interest is 2 of them were the first floating nuclear power plant in Russia, which is an exciting new technology to expand the use of nuclear power, and others in China and Korea and Russia. New construction in new countries. I think one of the things we want people to see is not only existing nuclear countries building new nuclear, but newcomer countries, as we call them. New countries that are building nuclear for the first time. As you can see, there was a number of new plants started in 2019, but when it comes to newcomer countries, you see only a small amount. You see up here in Belarus and Turkey. But we have other newcomer, I think it's Turkey, it might be UAE, but anyway, there's other newcomer countries here in yellow. There's many countries planning nuclear for the first time, and that's very exciting for the future. There's 52 reactors under construction, as King told you a few minutes ago. Here you can see where those are. Again, no surprise that the most units are under construction in China and India and Russia. But there are some interesting. You see units under construction in Bangladesh, in Pakistan, in Slovakia, in France, in Argentina. Now, one of the things that are very important when it comes to nuclear power is how well that the operating fleet is doing. what we can see is that the improving performance of the operating reactors continues. If you look at the right side of this chart, you can see that almost 2/3 of the plants in the world operate at 80% capacity factor or greater. This is fantastic. And in fact, more than 30% operate at greater than 90%. So one of the big lessons here is that nuclear plants operate very, very well. And at a time when we need clean energy for the future of society, we can see that nuclear plants operate well early in their life, in the middle of their life, and at the end of their life. So if you look at this chart, even plants that are 50 years old are operating fantastic. And that's very, very, very important. In fact, many reactors are starting to get older, and here you see some of the plants that are reaching 50 years of operation this year, and they're still operating. That's wonderful news. We also know that in the US, the first plants, starting with St. Lucie, have been licensed for 80 years of operation. So we expect much of the global nuclear fleet to continue to operate for some time yet to come and continue to contribute low carbon, reliable economic energy to the global grid. Now, as I said, we do have some new build countries. And what's exciting when you look at these 4 countries is that of these 4 countries, in the UAE and in Belarus, their first units are already in production. Unit 1 at the Baraka nuclear power station in UAE went into service this year. Unit 2 is almost ready to go into service, and units 3 and 4 are almost finished. Ostrovets Unit 1 was up at 100% full power about 1 or 2 weeks ago. So this is all very, very good news. And I think I saw yesterday that some key equipment has started to arrive at site for this project in Bangladesh. All good news. Now, as we know, demand for electricity continues to rise. And so if we're trying to decarbonize the globe, it's not only about getting us off fossil fuels that we've been using to meet today's demand, but we also have to meet the future growth in demand. And that means that we need a lot of clean, low carbon, reliable energy. If you look at some of these scenarios from the emissions gap report from the UN Environmental Committee, you can see that if we stay on our current track, we're not going to have the outcome we need. And look at the commitments that take us where we need to be. We really need to make a drastic reduction in carbon emissions between now and 2030. I don't think this is a surprise to anybody, but it's important that we all recognize it. And we also, very often these days, we only talk about the importance of decarbonizing. One of the things we forget, is that almost 1 billion people in the world live without electricity. And electricity is extremely important to quality of life. The other thing we forget is that in many countries, it's not only about carbon, it's about pollution. Now, in the IPCC pathway emissions to reduction, nuclear increases by an average of 2.5 times by 2050 in the 89 scenarios that they've prepared. So nuclear has to play a very important role in the future of meeting a low carbon world. In fact, nuclear is essential in the UN supported Deep Decarbonization Pathways project. And you can see here, if you look to 2050, nuclear becomes the largest source of electricity at 21%. Often people will tell you, well, renewables will be the largest source, but they forget that renewables includes more than one kind of electricity. Now, at the WNA, as part of the global industry, we've set a goal we call the Harmony Goal, which means we'd like nuclear to achieve 25% of electricity supply by the year 2050. What does that mean? That means we need 1,000 1 gigawatt size new nuclear plants between now and 2050. So in the next 30 years, we have to build 1,000 new large nuclear plants. If we look at the trends, we can see that currently we're building about 10 gigawatts per year. We need to triple that in the coming years to achieve this target. So the task is big, but I think as an industry, we are up to it. The Harmony program provides a framework for action, helping industry reach out to stakeholders so that barriers to growth can be removed. And you can see the 3 pillars here in this slide, but I won't go into it. The other thing that's been very exciting in nuclear industry is the innovations. A lot of people you hear today talking about SMRs. We talk about that here in Canada. In fact, later this week, we have a big conference on SMRs. And last Friday, Ontario Power Generation announced they're going to start planning for an SMR at their Darlington nuclear site. We have SMRs both grid scale and remote. We see the floating SMR here, so we can provide new sources of energy for remote communities, for mining communities. We see high temperature gas reactors that can be providing industrial heat to help industry have clean sources of energy to help decarbonize those industries. We have clean electricity to partner with the hydrogen industry to help decarbonize transport and other areas that are hard to decarbonize. And again, we have fast reactors and even fusion in the future to extend fuel utilization. It's an exciting time to be in the nuclear industry. So as we come to a close, we have to look at what the executive director of the International Energy Agency, Fatih Birol, has said. There is no sustainable energy future in the absence of nuclear energy. And with that, I hope I've waken you all up to be ready for the discussion for the rest of the day. I look forward to my next talk early in the afternoon. And with that, I thank you very much. Thank you. Back to you. Orpet.
Thank you. Thank you, Milton. Very nice presentation. Okay. Over an overview of the nuclear industry around the world. Now, I'm going to turn the next speaker that is also going to talk about the development of nuclear energy. This is my friend, Dr. Javier Palacios Hernandez. And please let me read here his bio. Okay. Dr. Javier holds a PhD in nuclear science from the State of Mexico Autonomous University and a master's degree in nuclear energy and bachelor's in physics and mathematics, both from the School of Physics and Mathematics of the National Polytechnic Institute. He also got a diploma in energy planning at the National Autonomous University of Mexico, and in conjunction with the Complutense University of Madrid. In 2019, January, he was accepted as a full academic member of the International Nuclear Energy Academy. In 2017, he received the State Science and Technology State Award on the category of Engineering and Technology granted by the State of Mexico. Since 2016, he has been accepted as a senior full academic member of the Academy of Engineering of Mexico. From 2010 to 2012, he joined the International Atomic Energy Agency as a member of the expert group of technical working group on advanced technology for light water reactors. In 2000, he was named National Research by National Council of Science and Technology, up to now as a part of Mexican National Research System. He is presently Vice President of Latin America section of American Nuclear Society. He was former president of Mexican Nuclear Society from 2018 to 2019, member of American Nuclear Society and Mexican Material Science Society. He is member of Nuclear Safety Committee for the Colombian INR1 Research Reactor. He has been at the Anahuac University, Technology, University of Mexico, and has been instruction in Laguna Verde Nuclear Power Plant. He joined the Research National Institute for Nuclear Research in Mexico, in 1999. From 1997 to 2000, was local technology, innovation, and control department. And from 2019, he is the general director of National Institute of Nuclear Research in Mexico, INI. That's a pretty comprehensive knowledge on nuclear area, Dr. Javier. Please, have the floor.
Thank you, Orpet. Thank you, Orpet. Good morning to everybody. I think it is there now. Thank you for the organizer committee to have this opportunity to talk to you small words about what is happening in Latin America after the interesting words of Milton, who has a pretty complete and nice overview of around the world. I will give you just a few words about what is happening in Latin America, how we are. Okay, now the electricity generation mix in Latin America, as you can see here, most of energy in Mexico and Argentina is coming from gas. In the case of Brazil, it is a lot of renewables through hydropower, mainly. And in the world, the nuclear is around 10.4%. In the case of Argentina, it's almost 6%, and Mexico about 4.5%. You can see here the share of electricity by source. As I mentioned before, mainly Argentina and Mexico is coming from gas, and Brazil from hydropower. Considering the low carbon sources, this picture can show us that Brazil is doing pretty nice in low carbon generation. Mexico, not so good, because it's only around 24% of electricity coming from low carbon sources. And Argentina is pretty around the world production. Just considering the nuclear electricity generation, you can see here, last year, Brazil generates this 16.1 terawatts hour. Mexico, 10.9, and Argentina, about 8 terawatts. With these figures are coming from these reactors. Argentina has these three big reactors, Atucha 1, Atucha 2, and Embalse, with a gross electricity capacity of 362, 745, and 656. Brazil has this Angra 1 and Angra 2. Most of you know and hear about those. And in Mexico, we have Laguna Verde 1 and Laguna Verde 2, both with a total generation capacity of 1,600 megawatts total. Argentina has now 3 operational reactors, as I mentioned, 1 under construction, and the nuclear share in 2019 was almost 6%. In the case of Brazil, 2.7% with one reactor under construction, Angra 3. Mexico, 4.5% in the nuclear share. Total Latin America is equivalent to 1.32% of the total nuclear share in the world. Now, considering the power reactors under construction and proposed, we know we have here Carem, a small reactor that it is under construction, and we're expecting that pretty soon finish and going to commercial operation. Also, they are planning in Argentina 2 units, one near Buenos Aires, and this is coming through an agreement to China, and they are planning perhaps a new Candu 6, but it's just on plan. In the case of Brazil, you have under construction Angra 3, and then you are working on Brazil. They are working pretty hard on it. They have 2 main projects proposed, 2 big projects, I should say, each one of 4 PWR reactors in the location of Pernambuco and Minas Gerais, as you can see here. In the case of Mexico, yesterday was the inauguration of the Mexican Nuclear Society Congress. And at that Congress, the words from the Minister of Energy was that the government is planning to build a small modular reactor in Baja California, South Baja California. We also has plans to build 2 more units on Laguna Verde. And we are thinking to have 2 more on the side of the Pacific Ocean of Mexico. Well, Argentina indeed is not just building a new nuclear reactor. They made a power upgrade for Embalse, a full refurbishment project, and now they increase the lifetime for another 30 years and another 35 megawatts power. And in April of 2018, Atuchawan extended the operating license until 2024. The case of Brazil, Angra 1 is going to expire his license on 2024, and they through Eletronuclear already start working on this plant life extension and license renewal. Electrobras is working with Westinghouse to extend this operating lifetime to Angra from 40 to 60 years. In the case of Mexico, Laguna Verde was going through a continuous power upgrades, starting with 5% in 1999, and now we extend up to 20% of the original power, around 810 megawatts each unit. After 30 years of operation, Unit 1 of Laguna Verde renewed his operating license and extended for 30 more years. In the case of Unit 2, we're expecting to have the same treatment from our regulatory body in order to extend the operating license of Laguna Verde Unit 2 from 2025 to 2055. Well, Latin America relies on hydropower, fossil fuels as sources of electric generation. The nuclear power share in terms of electrical generation is about 1/32 2% in 2019. Of course, it's only concentrated in Brazil, Argentina, and Mexico. There are plans to expand the nuclear capabilities on the 3 countries. Today, 7 nuclear power plants are operating in Latin America: Laguna Verde 1 and 2, Angra 1 and 2 in Brazil, Atucha 1 and 2, and Embalse in Argentina. These 7 plants, with 5 gigawatts in total, stands for about 139% of our nuclear installed capacity. Embalse in Argentina and Laguna Verde in Mexico has extended the operational lifetime by 30 years in 2019 and 2022 respectively. And I should finish with this remark: the world's commitment to reduce global warming by 2 degrees by 2050 will not be easy to fulfill if nuclear energy doesn't play an important role in the electricity generation portfolio. That's it. Thank you very much for your kind attention. Orpet, the floor is yours.
Thank you. Thank you, Dr. Javier. Nice presentation about the overview on Latin America. Now, we are going to the middle of our presentation to try to show the experience for the new technology reactors. For doing that, Dr. Federico Puente is coming to make the presentation. Let me read his bio. Dr. Federico is an experienced international energy expert with demonstration history of working in nuclear energy sector. He has a strong research professional skill in negotiation, power plants, proposals, management, leadership, sustainable development, economics, and teamwork. His career in nuclear energy fields on focus on nuclear safety, fuel management, reactor physics, and nuclear energy infrastructure, economics, and sustainability. He completed his PhD in nuclear engineering and Master of Science and major in nuclear power technology. He has a bachelor's in mechanical engineering. Okay? He has experience and work in many companies like TSO GRS in Germany, Industry, Areva, in Germany, Westinghouse in Sweden and Spain, research at Penn State University in the United States, and at ININ, Technology Monterrey in Mexico. Okay. Please, Dr. Federico, you have the floor.
Thank you so much, Mr. Chairman. Good morning in Brazil, good afternoon or good evening in the rest of the world. I should begin by asking, can you all see my presentation? Is it on the screen now?
Yes.
Thank you very much. Well, distinguished and dear panelists and participants, it's a great honor and pleasure for me to be here sharing this presentation with all of you. I should start by saying that the information that I'm about to present is of my personal ideas and reflections, and does not share by any means the vision of any institution nor any country. Firstly, I hope all participants, organizers, and their close ones are well and healthy. Also, I would like to extend a sincere gratitude and appreciation to the World Nuclear University and Abdan for their most valuable consideration and impressive work. The outline of my presentation, I will try to briefly jump and information related to advanced reactor technology. I will try to describe briefly the categorization, characteristics, and technology development of this advanced reactor technology. Let's try to set ourselves with which kind of technologies are we referring to? Well, usually we tend to classify or categorize the reactors in 5 different generations. For this particular presentation, when we think about advanced reactor technologies, it could come to our mind actually 3 generations, starting from generation 3, where we speak about advanced library reactors, then going through generation 3 plus, evolutionary designs, and of course, going into generation 4. I will actually go through some of the details of each of these generations in the next slides. But please allow me to begin with some general, maybe, characteristics. Remember, these are 3 generations, so this is in very broad terms. When we talk about advanced new modern reactors, of course, the very first thing that should come to our mind and has always been present in the nuclear industry is safety. Is the #1 priority. So as generations go on and new designs come in, of course, safety always tries to be improved, although it's already extremely safe, I should say. Then, of course, work on the amelioration of the economics of the reactors. And I will detail this a little bit further in the next slides. Also, enhance the flexibility requirements of the different operation and products. And one thing that actually has been mentioned, very well mentioned by the previous panelists, distinguished panelists, the sustainability of nuclear energy. It's already sustainable. And we try to even enhance on the sustainable concept of nuclear. So, increased safety margins. Within the increased safety margins, first of all, we think about engineered safety systems not requiring emergency power, no AC emergency power, and minimal external intervention. Also, of course, passive safety systems that rely on gravity, natural convection, or resistant to high temperatures. Then, of course, we also think about these reactors as inherently safer. So together with passive features, which require no active controls or operational intervention to avoid accidents in the event of any malfunction. In advanced reactors, the combination of fuel together with the coolant and moderator for the thermal designs result in a set of materials that present really high physical and chemical stability, very high heat capacity, and negative reactivity feedbacks. That, of course, also with a high retention of fission products. These improved safety characteristics also look forward in simplifying the licensing of these new nuclear power plants. Talking about the economics. Well, existing nuclear is a cost-efficient provider of low-carbon electricity. I'm sure that we are all aware of that, as was also very well explained in the previous presentations. But also, nuclear power plants are expensive. The capital cost of buildings MPPs is too high when it's presented to investors not considering the whole umbrella of benefits and advantages of nuclear power. So they tend to be scared with a high capital investment. There are many efforts on reducing this cost. And interestingly enough, this cost focus on reducing the capital cost including the construction costs. So not so much related to the nuclear steam supply system, but much more, or the greater opportunity being in the overall plant construction. So the idea, quite simple, on budget, on time. Also, there's other strategies focusing on the, of course, the construction of these power plants, like the modular construction, factory built and transported to the site to make it much faster. Talking about the economics of nuclear. Also the diversification of products, several potential areas of applications, electric and non-electric applications. Cogeneration, for example, process heat for the industry, hybrid systems together with renewable sources. This has become quite an interesting topic. Flexibility requirements. Flexibility requirements are related to the operation, are related, of course, to the construction, and are related as well to the products. One idea that is that we have probably hearing a lot in the last years is that we should not think just about base load, but load following. I should mention that this load following comes actually from the early 2000s, where some French reactors were already operating in load following. Actually, it's part of the European utility requirements. The load following part, related also to flexibility, as I mentioned before in the economic section, is the modular construction part. We can scale, we can increase the amount of power, the amount of heat that we are producing. The diversification of products, as I was mentioning before, also related to the economics of nuclear. So it's electric plus non-electric applications. As mentioned previously, the hybrid systems and cogeneration. Let's try, let me please start backwards from generation 4 reactors and then start building from there to the present time. Generation 4 reactors, well, there are 6 nuclear reactor technologies. 3 are fast neutron reactors, the sodium cool-fast reactor, the lead cool-fast reactor, and the gas cool-fast reactor. One can actually be fast or could also work in the epithermal, and to operate with slow neutrons. It is very interesting to say that all have higher temperatures. All of them have higher temperatures. The outlet temperature range goes from 500 degrees Celsius to 1000 degrees Celsius. All of them focus on advances in sustainability, economics, safety and reliability, and proliferation resistance. Most of these reactors are considered for a closed fuel cycle, increasing the efficiency of the fuel, reducing the waste production, and trying to be more economically competitive, because increasing the products in the output, as well as using the waste from the current library reactors as fuel. This generation of 4 reactors, in summary, enhance and strengthen the safety, economic competitiveness, sustainability, and proliferation resistance. They are focused on the flexibility, diversification of products, and sorry if I'm being repetitive with this, but it's extremely important to be actually to highlight this point. Hydrogen production, hybrid systems, and cogeneration. Modularity and the growth potential. They are actually thinking about scaling all these modules, making it easier to construct and making it possible to scale it in the future, as well as the flexibility in the operation, improved performance, technical innovations, and the most important, as mentioned in the previous presentations, building up and fortifying on the already characteristic of sustainability of nuclear energy. In a very summarized table from the World Nuclear Association, you can see these 6 reactors, which neutron spectrum they use. As I mentioned previously, there's one that can be fast or thermal, and actually there's 2 that can be fast or thermal. The different coolants that they use, the temperature, the outlet temperature that is of big interest when it comes to non-electric applications or cogeneration, the pressure, the fuel cycle. This is also of extreme importance when we talk about sustainability, working on closed fuel cycles. The size. You can see for some of these reactor types that we have different sizes. And I will be developing further on this concept in future slides. There's a very big interest on working in hydrogen production, electricity, and non-electric applications. The roadmap, well, this roadmap is from 2014, and it was actually thought, and is actually still, that 2 of these concepts, the ones on the top, the very high temperature reactor and the sodium fast reactor, are the ones that are leading this roadmap, with the other designs following. And it's expected that by the end of this decade, there's some, after some demonstration, there's already some deployment. Let me now build on the big interest from the private sector in this generation 4 reactors. This is not something that is in the R&D agenda of different countries. It's as well in the R&D agenda in the private sector. And actually last year there was a meeting between the Generation 4 International Forum and the private sector. Some of these companies, including some of these companies, to build on the R&D efforts, to include them on the R&D activities, on the R&D projects, and construct on that, building synergies and working on the development of these reactors. Now let me jump into something going a little bit closer to our times. Also a topic that is becoming of great interest for the audience, for the public, for the private sector, SMRs. There's SMRs, you will find there's actually very different models, designs. Let's begin by the ones that are the land-based water-cooled reactors. As you can see from the slide, there's different designs that go from as low as 25 megawatt electric all the way up to about 300 megawatt electric. This is important to mention, is land-based water-cooled reactors. I'm going to show in next slides marine-based, as was actually mentioned in the very first presentation, that is already working. Important thing of this and the next coming slides, there's, according to the IAEA, there's about 72 designs of SMRs now being developed and by different vendors that I will also show, focus on very different applications. Of great interest, the marine base. As was mentioned in the very first presentation, there's already one, there's 2, that they started at the end of 2019 and were commissioned in May, April of this year. It's already producing heat and electricity. Then we also have, of all flavors, these SMRs, in the sense that we have also for high temperature gas cooled reactors. These are especially interesting for non-electric applications. There's also been, I believe that actually China is constructing one of these at the moment. Then we have the fast reactors, SMRs. I missed to mention in the Generation 4 reactors that there's a considerable experience, very important experience on these reactors that is already the accumulation of many years of designs in France, in the US, in Russia. Actually, there's the BN 600 and BN 800 fast sodium cooled reactors in operation in Russia. China is building one. This also sodium fast cooled reactor. Going back to this slide, these are the designs of fast neutron spectrum SMRs. Then I also want to mention that there's molten salt. As you can see from these slides, there's a huge interest in SMRs. There's very different designs, many different applications, and also something that is quite interesting are the micro reactors. These micro reactors are from, of course, smaller power output. They are easily transported, sources of electricity and heat. They are fully factory built, easily and quickly installed and removed from site. These are, of course, like nuclear, reliable sources of demand-driven power, require minimal operation, capable of operating for several years, actually without refueling. These are also of great interest. There is, before jumping into the private companies and examples of these SMRs that are working, I would like to show you the non-electrical applications. As you can see from the slide, there's a very big range of outlet temperatures going from very different applications and very different of reactor designs. All the way from district heating, passing through desalination, industry for pulp and paper manufacture, going through the production of hydrogen, and finally, of course, coal gasification and so on. But what is important, one of the takeaways of this screen is the whole range of applications that we have to build on the sustainability of SMRs and on nuclear. So nuclear is already sustainable. The SMRs come to actually complement the sustainability of nuclear energy, building on the different applications, also on the different sizes, on different markets. It's actually, they are focused on depending on on-grid, off-grid, and so on. There's designs and there's technology development all around the world. In Europe, in Asia, in Africa, and in North and Latin America. And with this, I should probably stop because I don't jump on somebody else's time. But thank you so much for your time, for your attention, and I'll send it back to you. Orpet, thank you very much.
Thank you, Dr. Federico. Very nice presentation, very technological. You cover all the aspects of the new technology. Okay, now it's time to turn to Brazilian nuclear situation. So for doing that, I think the two speakers from Eletronuclear is going to start now this presentation. The first one is Mr. João Carlos Cunha Bastos. Okay, Mr. João Carlos, let me read the bio. Mr. João is an electrical engineer. He concluded his graduation studies in Rio de Janeiro State University in 1973. It's an old school guy. During the first 5 years of his career, worked as a thermoelectric power plants, being transferred to Angra 1 NPP, took part of plant commissioning activities, starting his specialization in nuclear generation. From 2015 on, he has been in charge of the operations and commercialization directorate of Eletronuclear. Today, he has 41 years of continuous work at nuclear industry. Mr. João Carlos, a pleasure to have you. You can start your presentation.
Thank you very much. Well, up to this time, I will speak in Portuguese because I know that we have simultaneous translation, and to avoid any kind of misunderstanding, I will speak in Portuguese, okay? So, bom, na tela,
you can see on the screen that I'm presenting my slides. The challenge for carrying out a major undertaking during this pandemic, the COVID-19 pandemic. And we have an opportunity to provide you with an overview of what's going on at Angra 2 in June of this year.
Bom, aqui nós temos a localização.
Here we have the location of our Angra 3, Angra 1, Angra 2, and Angra 3 plants. It's a Westinghouse reactor with 640 megawatt capacity, and it was built in January of, or started operations 1985, January. Angra 2 is a German Siemens technology with operation capacity of 1,350 megawatts. And then over to the right, you see Angra 3, our future plant. And we're going to have 1,405 megawatts with KWU Siemens Areva technology. And it will be online by 2026. Now, looking at the fuel cycle here at Angra, it's a 12-month cycle. And so each year, we have to recharge our reactors, both at Angra 1 and at Angra 2. So we have most of our material here on site. Things are stopped right now, particularly at Angra 2. And we had some issues with bringing in some of our fuel during the last stoppage at Angra 2. And so the cycle can be extended for up to 30 days, which we call stretch out. And so we have to make some small adjustments in our stops. However, when we went about understanding what impact the pandemic would have, we start to see that we had to change our plan and we had to stretch it out. And so that's what we did. We had to work on that during the pandemic. The pandemic has kept us from stopping. And so basically, one of the things that we have to show is how large this service is and how difficult it is to carry out the maintenance. all of our support for hiring the national and international service providers is important, and we have to provide fuel, as well as we have to make sure that we're meeting the technical specifications and all sorts of the corrective mechanism that has to be implemented to be able to handle the equipment and the outage of that equipment. We have to implement our projects using ways of being safe, and we also have to work with the nuclear industry and meet all the requirements and regulations over the long term. And so this is what happens when it is disconnected. In 2016, we had a planned outage. And so here I can show you the reactor, and we switched 52 ECs. This outage required collaboration across the company, not just at the operations, but also chemistry, the fuel staff, maintenance, quality, the procurement, social security, our legal department, everybody, the whole company mobilized to make that outage possible. And so we have this planning, and it's broad-based. Today, we have a risk evaluation that's carried out by the safety group, as well as evaluations for our safety. After the outages, and once we understand that we've met the objectives, then we have to figure out the leadership and what's the role of that leadership in the outage, both internally and externally. And we have to show what events occurred since the last outage and how we can avoid accidents and improve the quality of our work. All outage activities are controlled using flowcharts that contain all the requirements for the execution. How do you do operational isolation, the conditions for the plant, and the dependence on other activities. Then all of this has to be prepared in advance by the senior operators of the reactor. And another thing that's very important to keep in mind is the distance from Angra 1 and Angra 2 to our great centers that are in the United States at 8,500 kilometers of distance and 9,500 kilometers away, Germany. As everybody knew, in December of 2019 and at the beginning of 2019, we had information about at the end of 2019, we had the information about the pandemic, and our outage was planned for June. And so we had to plan everything around this new situation that created. Before the pandemic, this is what the outage was planned for. It was June 22nd, 2020. After the pandemic, we couldn't fulfill that date. The fuel was at the end of its useful life. And we needed to find a way to replace that, and that required an outage. So this date remained June 22nd. What was planned to be 30 days went on to be 22 days. We saw significant reduction in our scope because we had 4,500 licenses ready for the pre-pandemic, and just 900 licenses were ready for after the pandemic. As a result, we just weren't ready for this outage now. And then looking at the cost, you had 130 million versus 19 million reals. And then how many people did we hire? We had 1,250 Brazilians before the pandemic, and after the pandemic, 160. So this essential services had to be produced and carried out with our in-house staff. And basically, we were only hiring Brazilians because we had a lot of people on board from Germany and the United States, but basically we had to reduce how many we had from 150 to 5 foreign nationals. Now, looking at the need to adopt measures to mitigate risks related to COVID-19. Looking at the outage from 2016, we use that as a basis. We knew that it was one of the keys was to keep Angra 1 running. And so reducing the staff at Angra 2 to meet the measures for reducing COVID-19 spreading and contagion was important. And we had to consider this in our task makings and decisions. And so we had to take a lot of preventive measures. We had to do a serious evaluation to understand what we needed, how many people we needed to go ahead with our next outage, which is in 2021. And so we basically allowed this outage so that we could make sure that it would be very possible and safe, but at the same time, it was with limited capacity. Once the collaborators were involved, we understood that it was their individual and collective responsibility to keep everybody healthy. We were very seriously basing ourselves on international expertise, on nuclear organizations that have provided information on the different outages that have been carried out during the pandemic. And we looked at the different experience that they had, and we adopted it here. We looked at ways of mitigating the spread of COVID, and we used this manual right here from the World Nuclear Association. And we also had a specific card for our outage so that our employees and in-house staff had all the information with regards to this illness. How does it spread? What are the symptoms? All those kind of things. What would be the impact on family? How would you do that? And what about social distancing? We had to consider all these things and provide this major serious service to everyone, because it was very difficult to do this because, you know, social distancing and using masks and all of those things, all during this time that we were trying to do an outage, and this was very hard. So personal contact was basically avoided during the outage. We had to show people how to get into the different areas of Angra 2 using these dots on the ground. And we also did all of our meetings over video conference. And so even today we're in a video conference. It's the new normal. And so back in July at the beginning, we saw that people were using video conferences and they were having some difficulty with that. Then there was also the transportation for our staff to get to the plant. You can see that we spaced them out inside the buses to keep people far away from each other and at the recommended distances. Then also we had to look at the health of our staff, and we had to work harmoniously to make sure that they were safe and they were healthy. We would do the COVID tests, rapid tests every 14 days. And so we had health control as one of our main things, but then we wanted to reduce our direct contact with people. And then we reevaluated the scope of the outage, and we looked at what we could do. Furthermore, the country's borders were closed, so we couldn't get things in and out of the country. We couldn't receive or welcome any Germans, and we couldn't send any Germans out of Brazil. And so here in Brazil, our employees had to reduce how much work they would do because we didn't want them to bring things from outside of the plant to the plant. And so normally we hire lots of people, but this time we only had 169 professionals to work on this project. Training the professionals for the outage was carried out here at our Eletrobras Theater. It's called the Praia Brava Cine Theater. Everybody was kept at a distance. Also, our contractors were housed in housing that we provided by the company. And so we put them in different places so that they would have meals and they would stay housed here during the outage period. We were also keeping them sanitized, and this housing for the plant was very important because it helped us control the movement of people from the plant and back home. We also had risk control amongst our staff that was exemplary. The workers were guided to do self-evaluation before getting into our transportation. They had to check what the symptoms were, and then they were told not to get on the transportation unless they were feeling healthy. And so the medical department would also help us with this. Then also we were using the transportation was being used by the workers from point to point. And everybody had to use a mask when they got on to this transportation. It is fundamental. And we followed all the social distancing rules, and we made clear demarcations of where they were allowed to sit. And then we also supplied all the transportation for our staff that were hired for this outage. In addition, we substituted the inspection for, well, basically we were working with inspection, and we were making sure that people were following the protocols during the NP16 protocols. And we wanted to follow strict protocols for how we can work and how we should behave to reduce the spread of COVID-19, because this was a brand new situation. Now, let's look at planning for the outage. Basically, it was like a samba school and a parade. and a carnival parade. You can see here. Basically, as you all know, this is a world-known spectacle, and it requires lots of coordination. And the parade at the nuclear plant is something very similar. We have to bring in all kinds of different moving parts: engineering, social groups, technology, the radiological protection and operations. This situation with the pandemic made the coordination even more important. We had to think about who did we really need to hire? What kind of training did we have to provide? And another thing that we had to consider was that our own staff had to develop work that, or carry out work that others used to do for them. And so we went from 150 foreign staff to just 5. You can see how much responsibility fell on our staff. And so we were constantly doing safety tests, and this kind of test was very important. And it was carried out with 2 levels of pressure from 40 to 140 bars. It was a major undertaking and a major challenge for us. But what I can say is that we did learn how to fly when we were pushed into this situation. And so that's what we learned. We learned how to do solo flight and learn to trust ourselves and feel confident in our work, in our sector. And that's exactly what happened. We managed to do what we could, and we had to help ourselves and help each other, and it was successful. And then when we look at the activities on the reactor floor, we had a chance to work on counterfall. Now, the knowledge that we had of this technology was very important here, but we also bring our instructors from abroad to these situations, and due to this situation we weren't able to do that, and we didn't have that kind of supervision, and we did it on our own. And here I'd like to show you the tests that we've carried out that were done. Here you see the tests, the COVID-19 tests overall. In yellow, we see the number of positive cases that we had at Eletronuclear, and in green we have the number of positive cases of COVID-19 at Angra 2. So looking at all of these numbers for our staff who tested positive for the disease, 42 and 109. And then when we look at this yellow number, at the total number of hired contractors that had COVID-19, we had 270. The work at the plant didn't stop just because of the outage. Basically, 12% of the contractors had COVID-19 at Angra 2. And so the scope was reduced to reduce how much we spread the disease. And this all started 3 months before we carried out the outage. But despite all of this, our work at the plant and the security at the plant was maintained. And we always had one goal, which is that safety always comes first, no matter what. And it's very important to train people and make sure that everybody is monitoring each other. The rates of positive cases of COVID-19 were as low as possible. And during this pandemic parade that I said, we had 160 contractors compared to 1,250, which we usually call for this. And, you know, and so that's a huge drop. And then from 150 foreigners to 5 foreigners working, again, another major drop. And we had a very limited number of staff members working on this outage, particularly when we compare to other situations. So this was my presentation. I give the floor back to you. I thank you for this opportunity to be here with you. This was an excellent experience for us at Eletronuclear. It was unparalleled. We are very confident in our work, and as I tell all of my foreign colleagues, we know that we can rely on Framatome and Westinghouse. These are our top partners here for these technological issues. And we're going to move forward and we're going to keep on working. But things have definitely changed because the COVID-19 situation has changed how we look at things and how we take on our challenges so that we can continue carrying out all of our work. I thank you for this opportunity to be here with you, and I give back the floor.
Thank you, João. Very comprehensive presentation of the enormous effort Eletronuclear has carried to make this stop of Angra 2. It's a very nice work. Thank you. Now let's turn for our last presentation today in the morning. It's due with the progress of Angra 3. Again, it's a representative from Eletronuclear that's going to be here, Mr. Marcelo Gomes da Silva, okay? And let me read briefly his bio here. Mr. Marcelo is electrical engineering, formed by University of Federal Fluminense, and postgraduate in energy economics in University Federal of Rio de Janeiro. Works at Eletrobras Eletronuclear, having participated in design, erection, and commission of Angra 2. After 10 years, he was moved to strategic planning manager at Eletronuclear. Presently, he's leading the new projects development department. His main tasks are resumption of Angra 3 and the future expansion of nuclear generation in Brazil. As an external expert of the IAEA, he is also working several assistance missions to countries establish new nuclear power programs such as Chile, Nigeria, Uganda, Saudi Arabia, and Egypt. Okay, Mr. Marcelo, please come to your presentation.
Thank you, Orpet. Thank you, everyone. First, I would like to thank Abdan and the WNA for the opportunity and for the invitation to participate in this panel. It's a very exciting moment in Latin America as a whole for nuclear power. Let me start sharing my screen here. I'll make this presentation today. I'll be talking a little about a little more than just Angra 3. I'll be talking about nuclear energy in Brazil as a whole. Of course, Angra 3 is unavoidable, but I'll be talking also about the future of energy, nuclear energy in the country. So to get started, this is my agenda for today. I'll give a brief introduction on the electricity market in Brazil. Then I will talk about Eletronuclear, our company. Then we'll go through Angra 3, an outline of the present situation and the efforts that we are making to complete the plant. Then I would like to speak a little about the current national plans for the future of energy, nuclear energy. And finally, some of the activities that we have to make to realize those plans. The electricity market in Brazil Brazil energy mix is mostly hydro. We're over 68% hydro, and we're, of course, in the recent years, we have new hydro projects are getting more and more difficult to license due to the questions related to land use. So we also have had very recently a very large deployment of new wind and even more recently solar photovoltaic. But keep in mind that Brazil energy mix is mostly renewable. It's already mostly renewable. We are today where a lot of countries in Europe plan to be in 2050 regarding the renewable energy mix. Also, Brazil has a very steep growth in energy demand. Of course, it's a developing country. There's a lot of issues to be solved. There's a lot of progress to be made, and energy plays a role on that. We had in 2020 a decrease, a negative impact on electricity demand in the country from April onwards. But in the second semester, the recovery has been surprisingly good. So it will be interesting to see how the situation evolves as the year closes and we start the new year. But it's expected that in the long term, there will be a strong growth in electricity demand in Brazil, which presents some challenges to put new generation on the grid and also observing the goals, the climate change goals that the country has compromised. In this overall picture, we strongly believe that nuclear as a stable and clean energy source has a very important role in the Brazilian energy mix. Market in Brazil is mostly deregulated, and we have separation of generation, transmission, and distribution. In the past, Eletrobras, our parent company, it was the main and almost the only electricity company in Brazil. But in the 90s, we had this deregulation. A lot of sectors were privatized, and the market in Brazil is a mix of private companies and still some large government countries. Nuclear generation by law is reserved for state companies. So Eletronuclear, our company, is, we have two assets in operation as Angra 1 and 2, as Dr. João Carlos has already shown us. And we have Angra 3 under construction. Angra 3 is a twin plant from Angra 2. It's a KWU convoy design, and it's about 67% built. As I said, Eletronuclear is a subsidiary of Eletrobras, which holds ours about 99% of the company shares. We have some very minor shareholders as well in the company, but they are mostly state owned. So this is Angra 3. The construction actually started in 2009 when first concrete was poured on the plant, but it stopped in 2015 due to economic reasons. There was a major economic reform in the energy sector in Brazil. As a result, Eletrobras had a very sharp cut on the revenues and could not invest money on the project anymore. Shortly thereafter, we had those corruption scandals that became public, and the construction was already stopped by then. after clearing all those contractual issues and all that, we are ready to resume the construction. We have some investments already in place to restart construction, as I will show you. So overall progress now is 67%. We still need about 55 years actual construction for completion of the plant, and our goal is to have it, the plant online by the end of 2026. This is another view here of the main structures. As you can see, and this is our roadmap for finishing the plant. I know that many have been following this quite closely. We had a very long way to find how to restructure financing of the construction and how to find a good model for completion of the plant. There have been a lot of support from the federal government on that, and since October last year, we have a contract with the National Development Bank, BNDES, to help us in finding or structuring this new financial and contractual arrangement for the construction of the plant. We are now, we have completed many of the tasks that we had before us. And now in this next month, or this next week, BNDES is launching a request for proposal for technical services that will be performed next year. And these services are mostly due diligence, technical due diligences, operational due diligences, so that future investors, future EPC contractors, they have a very clear and independent idea of what is the status of the construction, what is the status of the supply equipment, and so on. So this is happening in the beginning of next year, all those due diligences. And we expect to have the implementation of the model, which means securing financing and signing EPC contracts by the end of 2021. This is still a very hard work before us, but we are very enthusiastic about it, and we believe we can accomplish that. An important hallmark we had in June 2020, we had a government resolution. It's the Council of the Public-Private Partnership in the government. It approved a report by BNDES that outlined the model for completion of the plant. This report defines that a separation between engineering risks, which will be taken by an EPC contractor, and the financial risks, which will be taken by a pool of financing institutions. Also, the CNPA, which is the National Council for Energy Policy, will be monitoring the project. And as a result also of this decision, we started this phase 2 of our contract with BNDES, which is the actual implementation of the approved model. In the meantime, we're not standing still. We, as a company, we had to take some actions because all those governmental fronts could take longer than expected. So we started a critical path acceleration program. This program consists of some minor construction activities aimed at the critical path of the overall time schedule of the construction, so that we can keep our goal, we preserve our goal of having the plant online by the end of 2026. So by the first semester of next year, we expect to have some contracts signed for those civil and electromechanical erection works on those specific tasks. And we expect to have works online already on the second semester. I'm talking here mostly about the nuclear island and completing the reactor building, which are the main tasks or the main targets of those critical path acceleration program. Moving on to the overall national energy planning, there's a document that's about to be issued by the government. It's the Brazilian National Energy Plan 2050. It's in public consultation right now, and we expect it to be out in its definitive form very soon. This plan has an outline. It lays out some strategies, and there will be an action plan following it, which will be how to deploy this strategy. And finally, there will be a monitoring action to monitor this deployment. So it's a three pillars approach. As I said before, this plan expects a large growth in electricity consumption and electricity demand. As I said, it's we still have a very low per capita use of electricity in the country, and we expect to change that situation, and we need a lot of energy for that. Well, this is those figures here are well known of the audience. It's about the development of nuclear power in the world. So the PNE, this national plan, it has some scenarios depending on the deployment of solar photovoltaic energy in the country, but the space for nuclear is from 8 gigawatts to 10 gigawatts, which means about from 8 to 10 new plants, depending on those scenarios. The plan also goes on to outline the challenges or that nuclear must face in order to realize that goal. So it talks about the communications challenge of nuclear energy, which is fundamental for our business, but also talks about some update of nuclear infrastructure in the country, a good assessment of the overall nuclear generation expansion in the country, considering not only energy demand, but also nuclear energy policy in the country, acknowledging that nuclear has a very important role, which surpasses just the generation of electricity. It also brings life to a whole industry and a whole set of applications such as nuclear medicine and industrial uses of radiation and so on. Life extension of the plants and also uranium mining. Brazil is has a very large reserve of uranium, and we believe that those reserves are even higher than already known. Some tasks on how to achieve, how to face those challenges are also outlined in this document. So the interesting thing here is that there's a federal document, a governmental plan that first considers nuclear energy as as having an important role in the growth in generation in the country. The same document also recognizes the challenges that must be met and how to address those challenges, which is a very, it's quite new in the country, and it's very, it's an evidence of the support and an evidence of how nuclear is in the picture of the state of Brazil. New power plants to be built in Brazil. We expect those plants to be Gen 3. And we are considering sites that can support from 4 to 6 units. I think it's a global trend. You see that a lot in Asia. There are obvious economies of scale on that. And I can say if we had more space in Angra, we definitely would build 1 or 2 more units there, but unfortunately we don't have that possibility. So we are talking about also pressurized water reactors technology, which is the technology that is established in Brazil. And for that, we have made a survey of the national territory, screening the country for potential sites for deployment of those new nuclear power plants. We have used the EPRI site selection procedure, and we have done all those successive grids or successive screenings of areas until we have a range of candidate areas and a few potential sites to offer for the government. This decision is not a decision of Eletronuclear. We're just the operators of those plants, the construction and operators of those plants. It's a governmental decision that will be done. It also has some political ramifications, of course. And we expect that once that decision is made, or a clear indication of which sites or which areas we should look in depth, we will then proceed to further investigate them. So this is the result of this process. Those red areas, they are the large, big candidate areas in the country. We have a total of 40 areas. We have here also a zoom on the northeast of the country and the southeast of the country, which we have some signals that will be the areas where most probably those new deployments will take place. So we have some very good sites. At Eletronuclear, we also plan to have a further review of this process, trying to identify a few more areas or some good potential places, mostly on the shore. As you can see, almost all those areas that we have found are inland. And the reason for that is that on the coast of the country, we have mostly very large cities. We have also sedimentary soil, which we are trying to avoid for the construction of those new plants. We had this criteria, we applied them quite strictly. So most of the sites we have are inland. So we plan to have a further look at the coast to see if we can find some more suitable places. And finally, a roadmap here of the activities we have to do to look for until we can build the next plant after Angra 3. So up to 2014, we had this site selection study performed. We have issued also an RFI to major vendor, and we have also done some preliminary feasibility studies. What we need now is an actual decision and selection of some sites that will be further analyzing in detail. And we are also preparing a PPA, a plant parameter envelope, so that we can license the site to a plant parameter and not to a specific design or a specific reference plant, which is a change of licensing philosophy in Brazil. We also plan to have some technology qualification criteria so that in a few years we can have an early site permit, and a process quite similar to American CFR 52. We plan to have this early site permit as a license for the plant permitter, and we also plan to have a power purchase agreement. With those two things in hand, we can go for a bid, a competitive process for selection of the vendor which will be furnishing the plant. New nuclear build is a major task, and we don't see that Brazilian government will have all the resources or the financial resources in place for that construction. We need some sort of private partnership in the project. But in the end, to meet the law requirements, Eletronuclear will be the operator of the plant. So this is our roadmap for the future build of nuclear power in Brazil. And finally, I would like to give us some disclaimer. We are part of Eletrobras, which is a public traded company in the stock market. And so please, no indications that were given in this speech should be taken as investment decisions or prospects. Thank you very much for your attention. I return to Mr. Orpet. Thank you again.
Thank you, Marcelo. Very nice overview of Angra 3 and also the planning for the new nuclear power plants in Brazil. Okay. Okay, let's. I think it's time to start. Time now is 11:05. To start some questions and answers. Let's see if I can summarize and see like that. During the presentations, I was looking most of the questions, and I try to follow here the same order of the presenters. Okay, and related to the presentation of Mr. Kaplan, there is questions on what the change necessary for business model around the world to achieve this aggressive growth of nuclear. And he direct on the chat answered that to be an issue that will be dealt at the afternoon presentation. So it's a good flag for people that wants to know how to couple with this new model of business and finance to attend the afternoon sections. Okay. But anyway, Mr. Kaplan, I think there is still a question here that is related to the carbonization goal, if it is realistic or not, and the contribution of the nuclear for that. Could you explore a little bit more on that?
Sure, I'm happy to answer. Thank you, Orpet. I think the decarbonization goal, we didn't talk a lot about the requirements this morning, but we all know that meeting carbon targets by 2035 or 2050 are very difficult. Now, many countries have even said that by 2050, they want to be have zero carbon or carbon neutral. I think it's clear, every study shows that the task is very large and you cannot meet it with wind and solar alone. I mean, in Canada, we are lucky, like you in Brazil, we have mostly hydro resources. But when you look at the future, the IEA in their report that came out last year suggesting looking at nuclear energy in a clean energy world is saying it can't be done. Here in Canada, we had our own Minister of Natural Resources say that his net zero ambitions can only be achieved if nuclear is part of the mix. So I think we need to be more aggressive, and we need to understand that no one technology will deliver what we need to decarbonize the world in the future. And nuclear energy will have to play a major role. Thank you.
Okay, thank you, Mr. Kaplan. There is a lot of, thank you for the explanation. By the way, there is a lot of messages on the chat. Congratulate all the speakers for the very good presentation. So you are all speakers, congratulate with this. And let me turn it to Dr. Javier. So talking about Latin America. And the question maybe I can summarize here is that, well, we have three countries that holds, sizable nuclear program. Brazil and Argentina, that also has fuel, very large fuel cycle, and also Mexico. Relating to the other countries, it is, most of them are smaller and with gross internal revenue lower, and it's difficult to have programs for big nuclear power stations. The question is, you say that, well, maybe if development of SMR in the future can help these countries to come on board on nuclear.
Okay, thank you for the question, Orpet. Yes, I think the role of small modular reactors nowadays is getting very important for countries that doesn't have these interconnected electrical networks, or for those isolated areas. Even in places like Mexico, we have an interconnected network, electrical network, but areas like Baja California Baja is not connected to the network. So that's why we are thinking there 100 megawatts or less small reactor. In Latin America, countries like perhaps Uruguay, that has a very small network size, like 2 gigawatts or so. One big reactor is worth the half of the capacity of the country. So for those countries, small reactors it could be a solution. I was attending 3 months ago for a forum of natural gas for Central America, for example. And they are trying to go into the combined cycle plants for 50 to 60 or maybe 100 megawatts in this Central America area. I think for those countries, small reactors, it's a real competitive option, even cheaper. I will give you an example. For example, in Mexico, Baja, we perform the economical analysis. The electrical cost or electricity cost for that area using combined cycle is about $80 per megawatt. If we switch on the program with the small reactors, we will get like 40 megawatts, $40 per megawatt. So half price of the present projected cost in that area. So these small modular reactors are very, very competitive to combined cycle plants. So for Central America, all this area could be covered with these small and modular reactors. We should really perform some research and development, mainly the economic area, in order to promote and to help these countries to move into this direction.
Thank you, Dr. Javier. Nice answer. Okay, Now I'm turning to Dr. Federico that make a nice presentation, the models of generation 3, 4, and also present us the large variety that you have in SMR being developed. But I think the question I have most here is that you see that in Latin America, there is initiatives from Mexico to have another 2 or 3 power reactors, Argentina another 1 or 2 and probably 3, and Brazil, Mr. Marcelo presents, there is a planning to have at least between 8 and 10, probably less. It depends on the size of the reactor. The question is, for these new plants that are coming, what's the likely to have generation 4 to be as the technology used on this new company?
Thank you very much, Mr. Chairman, for this very interesting question. I hope you can all hear me well. I sometimes see the message that the connection is unstable. Thank you so much for the question, and thank you so much for the time. Yes, it's always, when we talk about generation 4, we tend to think about the generation 4 as a future generation. It's actually closer than we think. I believe that for very experienced countries or developers and so on, of course, it will be much easier to deploy this technology. One thing about generation 4 and SMRs combined is that, as I was trying to depict in my presentation, is that there's many designs and many alternatives. Some, of course, are looking into the generation 4 technology to go through other applications to increase the sustainability and so on of generation 4 reactors and nuclear. We should see these technologies as a complement. It will not be a substitute. I think, of course, that for the region, for the time being, probably it will be much better to go with SMRs based on generation 3 and generation 3 plus these technologies. Because, of course, when we are talking about first-of-a-kind costs, or they want experience in construction, experience in operation, experience or certified designs. But perhaps one of the things that could be of interest, if the design allows, are with these transportable reactors that actually the main purpose will be to sell the product, the electricity, the heat. So not to sell the reactor itself, but to sell the product that is needed perhaps for the industry or the application. I think it has great potential around the world, but perhaps, of course, always for the beginning, maybe generation 3 plus will be more applicable for this, for the region in the short term or medium term. As it was very well mentioned by the previous and other presenters, there's many benefits and advantages from the economic viewpoint, from the sustainable viewpoint, for the competitiveness when we look on the long term. So these reactors can bring all together and can help in many different fields. So like building on what it was just mentioned really well by my distinguished colleagues in the panel, is that nuclear is quite fit for decarbonizing or helping in the effort of decarbonization and electrification. We need to think that in all the world, there's mainly two problems. The problem with the quantity of electricity that is needed. So there's this today, like it was very well mentioned in the presentations, there's people that lack access to electricity, and that's about quantity. And then quality, that we are trying to address the problems of climate change. Nuclear has the potential for. Of course, we have to consider and work on informing, as it was also really well mentioned by my colleague, Mr. Marcelo Gomes, about informing the society, getting the social license for that. And I will stop here for that question. Thank you, Mr. Chairman.
Thank you, Dr. Federico. Okay, that's the answer. Now I'm going to turn to João. João, it is you shows the tremendous effort that ETN has done during the stop for Angra 2 and a lot of reduction on efforts and things like that. You know, during this pandemic, we talk about the new normal. My question is, based on the experience that you had with this lot of effort to perform this, Eletronuclear is having an initiative to review the procedures for the stopping of refilling the reactors, because it looks like you may have found a lot of points of economy, efficiency, and also to promote inside and try to reduce the time, try to reduce the cost of the stop. Have you, Eletronuclear, start some studies on based on the data that you got from this stop?
Well, I will answer your question in Portuguese, ok?
Okay.
Bom, existe estudo para aumentar o ciclo de Angra 1 para parar a unidade.
There is a study for performing the outage of Angra 1, not only each 12 months, but every 18 months. The fabricator of Unit 1 has this experience, and so technical specifications and all tests required by ASME certifications are already known to us.
In this way, we can increase the fuel cycle of Angra 1. And Eletronuclear is now starting to think about this current situation, which is the cycle. Now, for Angra 2, all the experience from Germany is not based on very far off places. Maximum, we can say that they have 14 months, and they have an outage every 14 months, or a stoppage every 14 months in Germany. And the Germans have very rigorous criteria. They require tests in the short term, and they don't allow situations that extend to 18 months. But Eletronuclear already is working on its cycle in Angra 2, and it's currently at 13 and a half months. And we were trying to reach for 14 months, but these would be the cycles that we would place here at the Álvaro Alberto Central. 13 months for Angra 1 and 14 months for Angra 2. More than this would mean that we would set these units in a risky situation. We don't think that this is a very good idea. And so we are basing ourselves on international nuclear experience. The American research shows us all kinds of knowledge about how to reduce this kind of risk. But we also see that the Germans in particular, they say don't go beyond 14 months. And that's what Eletronuclear is setting itself up for. Unit 3, once it's online, we know that we have to talk about improving these operation cycles so that we don't have one stopped and the other also stopped. We can't keep them all off. They have to be set up so that they have no more than 2 outages per year. This has to be our maximum. And so I'm going to give the floor back to you.
Thank you, João. Thank you.
Thank you for the answer. Thank you. Thank you so much. Okay, the administration is asking me to close the session, but Marcelo, I keep holding a question for you. Okay, I hope it'll be a fast question. You present us the planning for, it's more than planning. The execution planning of Angra 3 and also the new ones. Let's focus on Angra 3. We still have the goal to have in the end of 2006 to connect to the grid in Angra 3. And then, since it's not usual to have delays, and the delays are going every time, in your point of view, that it is direct managing this situation on the critical path, what is the more risky activity for not roll over the end of 2026?
Well, we have a lot of very, very important tasks that are relevant and must be accomplished in good time in order to make this 2026 goal achievable. I think that the financial restructuring by the end of next year is very relevant. And also one important thing is the timing for the EPC contract. The signature of EPC contracts. It's a very complicated contract. It's a large contract, very high costs, and demand a lot of interactions between the bidders and the Eletronuclear, maybe some visits onto the site, some preparation of the bids. I think this is very critical for the success. Other activities in construction sequences, they are manageable, right? It's something that in a way or another you can take care of. But those big signing of those 2 big contracts, the EPC and the financial, I think are the most relevant and the most difficult and the riskier for the project as a whole. Thank you.
Thank you, Marcelo. Thank you. Very short and direct answer for the question. Thank you. Well, I think it's time to close the section. I want to not only to congratulate, but also to say thank you to all the speakers. We have a very nice section, a lot of issues were touched and talk and a certain level discuss. And I also thank you, all the audience, all the participants.